So apparently the video cut off right before the end of what I was trying to finish here with number 3 and number 4. I think if I just went back and watched it again, I did not quite get to this part right here and then all of part 4. So I think I was saying at the end that we could use 2 pi as the last test point. And when you do, since 2 pi and 0 basically give you the same values, I know that we were going to get a negative value here, which means concave down. So what you should see there, and this is kind of important, so I'm going to have to finish this video real quick here, is that it goes from concave down to up to down and then to down again. So at 3 pi halves, there is no change of concavity. So 3 pi halves does not end up giving us a critical point for the second derivative. So there's no inflection point there, just an inflection point at pi 6 and at 5 pi 6. And in order to find the inflection points, because they are points, it's an x and a y coordinate, you have to take pi 6 and 5 pi 6 and actually plug those in. And I kind of did a little bit of scratch work right here. Whoops. Oh boy, come on. Right here, did a little scratch work. So plugging in pi 6 was this top one right here. Cosine squared, or cosine of pi 6, is square root of 3 over 2. But when you square the square root of 3 over 2, you get 3 over 4 right here. And then sine of pi 6 is a half. So 2 times a half is 1. So you get 3/4 minus 1, which is negative 1/4. And then when you plug in 5 pi 6, cosine of 5 pi 6 is negative square root of 3 over 2. But again, squaring that, because it's cosine squared, gives you 3/4. And then sine of 5 pi 6 is still a half. So 2 times a half is going to give you minus 1. So 3/4 minus 1, once again, is negative 1/4. So finishing off our last video here, the inflection points are at pi 6, negative 1/4. 5 pi 6, negative 1/4.